Now that we remember what happens when we have a factor of a polynomial function, what we're going to do is we're going to check to see which of these polynomials could have x minus 2 as a factor. And we can do that really easily and quickly using synthetic division. Remember, what we're looking for is a remainder of 0. If we get a remainder of 0, then we know that our polynomial function has a factor that is equal to x minus 2. So what we're going to do is just do synthetic division here. So x minus 2, set it equal to 0 and solve. X is going to be equal to 2. Okay, I'm going to move this up now. I know that 2 is going into my little box, and then I just check the coefficients. It's in standard form. There are no missing degrees, so I write my coefficients, 6, -7, -5. Do my synthetic division, drop the 6 down. 2 times 6 is 12. -7 times 12 is, -7 plus 12 rather is 5. 2 times 5 is 10. I have a remainder here of 5. Therefore, I know that it is not, x minus 2 is not a factor of polynomial a of x. Now let's check b of x. I'm going to do it to the side over here so I have a little more room. Again, 2 goes inside the little gazenta house. 3, 15, -42. Do my synthetic division, bring the 3 down. 2 times 3 is 6. 15 plus 6 is 21. 2 times 21 is 42. There's a remainder of 0. So yes, I know that x minus 2 is a factor of 3x squared plus 15x minus 42. Now we'll check c of x, 2, and then our coefficients. There are no missing degrees. It's in standard form. 2, 13, 16, and 5. Drop the 2 down. 2 times 2 is 4. 13 plus 4 is 17. 2 times 17 is 34. 16 plus 34 is 50. 2 times 50 is 100. 100 plus 5 is 105. My remainder is not 0. Therefore, x minus 2 is not a factor of that polynomial. Next one, 2. No missing degrees. It's in standard form. 3, -2, -15, positive 14. Drop the 3 down. 2 times 3 is 6. -2 plus 6 is positive 4. 2 times 4 is 8. -15 plus 8 is -7. 2 times -7 is -14. Remainder of 0. Yes, x minus 2 is a factor of polynomial d of x. We have 2 more to do. E2. Well, that was a bad 2. There's a better 2. I have no missing degrees, so 8, -41, -18, 101, and 70. Drop the 8 down. 2 times 8 is 16. -41 plus 16 is -25. 2 times -25, -50. -18 minus 50 is -68. 2 times -68 is -136. Check my arithmetic. I'm pretty sure that's correct. 101 minus 136 is -35. 2 times -35 is -70. I have a 0 remainder. Perfect. I know that x minus 2 is a factor of that polynomial. Last but not least, let's check f of x. The 2, 1, 5, -27, negative 101, and negative 70. Drop the 1 down. 2 times 1 is 2. 7, 14. That is negative 13. 2 times negative 13 is negative 26. Negative 127. 2 times negative 127. I can tell already that this remainder is not going to be 0. That is negative 254. And when I add these, I get negative 324. So I know that x minus 2 is not a factor of that polynomial function. Okay, so feel free to pause at any time. You should be doing these polynomial, do this synthetic division on your own. It's good practice. And remember, this is a skill that we need to develop. Okay, number 2 says select one of the polynomials that we said does not have x minus 2 as a factor and explain how we know it's not a factor. Well, why don't we just go to the easiest one? And the easiest one is polynomial a of x. And notice, I know this is not a factor because the remainder was not 0. The remainder was, in fact, 5. So we can say that. We can come down here and we can say, since a of x divided by x minus 2 had remainder equal to 5, then x minus 2 is not a factor. Okay, if you've not already done so, which we did, we want to divide the polynomial by x minus 2. What is the remainder? If I remember correctly, my remainder was 5. Okay, so I know that the remainder there was 5. Now, what we're going to do is we're going to list the remainders for each of the polynomials, and then how do those values compare to the value of the function when x equals 2. So for a of x, and the polynomial a of x was 6x squared minus 7x minus 5. Now, when we divided that by x minus 2 using synthetic division, the remainder was equal to 5. Now the question is, what is the function a evaluated when x is 2? And how do I do that? Well, I just plug 2 in for all the x's. Minus 7 times 2 minus 5. And this is something that we had already talked about. So this is just more of a make sure we prove it to you. 2 squared is 4, so this is going to become 6 times 4. This will be negative 14, negative 7 times 2, and then minus 5. 6 times 4 is 24, minus 14, minus 5. 24 minus 14 is 10, minus 5. That is equal to 5. So notice the remainder and the value of the function evaluated whenever x is equal to positive 2 is the same. Now, what we'll do is we will evaluate b of x as well, but we're going to do it a little bit quicker. B of x was equal to 3x squared plus 15x minus 42. Now, if you have a graphing calculator, something that's really handy, is that you can store your x value. Let me make my calculator fit here. You can store your x value to be the exact size that you need it to be. Well, I'll make the screen fit. How's that? Bear with me while I get this figured out. Okay, so there's my graphing calculator. Now what I can do is I can take 2 and I can store it as my x value. Then I hit enter. Now I have my x value is stored as 2. Okay, now all I have to do is type in the function exactly as I saw it, and b of x was 3x squared plus 15x minus 42, and when I hit enter, I get the output of that function when x is equal to 2, and in this case, the output of that function when x is equal to 2 is equal to 0. And if you recall, that's exactly what our remainder was. The remainder here was also 0. I can do the same thing for c. I'll do one more. I'm going to evaluate function c at an x value of 2. And function c was 2x cubed, c of x, not c of 2 here. C of x was 2x cubed plus 13x squared plus 16x plus 5. Now I can go to my calculator and I just type in that function, 2x cubed, 2x to the third power, plus 13x squared, plus 16x, plus 5. And I get a value of 105. So my function c, evaluated when x is 2, was 105. And the remainder, when I did synthetic division, was 105. Okay, so what we're just showing you is that when you use synthetic division and you divide out a polynomial, whatever remainder you get is going to be the value of that function evaluated at that x value. Okay, and we talked about this before. This is just a way to show you that and to prove to you that that always works. So what I would encourage you to do is, the video is almost over. I would encourage you to go in and evaluate function D whenever x is 2, function E whenever x is 2, and function F whenever x is 2. And you will see for yourself that whatever you get is going to be equal to whatever remainder you had. Okay, so we will pick up. We have one more video for this lesson, and then we'll be done, and you'll be ready to do your classwork.